Okay, remember when I told you back in Objective 2 to be very thankful when the problem is given to you in factored form, because it wasn't always going to be given to you in factored form. Well, guess what? Now it isn't given to you in factored form, so the very first step you're going to have to do is factor it. Now, our first three examples are just practicing differing types of factoring. So, factor completely problems 1, 2, and 3. Now, this first problem is pretty much the basic factor process, the trinomial factor process, with the exception of that first term is not x squared, it's x to the fourth, which means my first two terms are not x and x, they are x squared and x squared, but the rest of the problem is the same. What are the factors of positive 21 that give you a sum of negative 10? And it's negative 7 and negative 3. Now you could FOIL this if you want to check, and you would get x to the fourth power minus 10x squared plus 21. Now the next problem, problem number 2. Obviously it's not a trinomial, it's a binomial. So let's check for a GCF. Do the terms share anything? And yes, they do. They share a 5 and they share an x. But because the first one is the negative, let's pull it out as a negative 5x. So we found a negative 5x as a common factor. So factor out a negative 5x and just see what's left. This would be x squared. And then the second term would be 45 divided by negative 5, negative 9. And the x's would reduce and cancel each other. So I'm left with that. But now hiding inside the parentheses is a difference of perfect squares. So we have one more step to go on this part, not on this part. So the fully factored expression is negative 5x times, now I just have to factor this by differences of perfect squares, x plus 3 and x minus 3. Now the last problem down here, somewhat the same as the first one, x to the fourth, then x squared, then the constant. So I know I begin with x to the second here and x to the second there. It's the only thing that can possibly happen. Now, what are the factors of negative 2 that give me negative 14 as a sum? Well, negative 16 times positive 2. And again, this one can go down further because it's a difference of perfect squares. X plus 4, x minus 4, and then x squared plus 2. On example number 4, we're going to bring graphing back into it. But you can see before we are able to graph it, the instructions tell us take f of x and subtract g of x. Then factor it, then sketch it, labeling the x and the y intercepts. It sounds like a lot, but it really isn't. So let's start with f of x, which is 2x cubed minus 11x squared. And then subtract g of x. Now remember, the big thing about that is, since g of x is a binomial, we're subtracting this binomial, 9x cubed minus 31x squared. So that subtraction sign is ultimately going to get distributed. So we've got 2x to the third power minus 11x squared minus 9x cubed, and then that would be plus 31x squared. Now I can combine like terms. 2x cubed minus 9x cubed is negative 7x cubed. And then if I start off with a negative 11x squared and add a 31x squared, that makes plus 21x squared. So that's what f of x minus g of x is in its simplified form. Now, the next thing is, if we can factor it, which we can, let's go ahead and factor it. So the two terms share negative 7 and they share x squared. So I'm going to factor out a negative 7x squared because that's the common multiple. So if I do that, my factor now looks like the negative 7x squared that we factored out as the common factor. And then what was left was simply an x in this first term, and then a minus 3 to end with. Now, this is the problem in its fully factored form. Now, if I want to go ahead and sketch it, I'm going to set it equal to 0. I'm going to make it y, or I could make, well, I don't want to use f of x because we've already used it. So y equals negative 7x squared times x minus 3. So this is what we're ultimately graphing right here. So what do we know? We know the x-intercepts. There's an x-intercept at 0, because remember what you do, you set the factors equal to 0, negative 7x squared equals 0, which means x would equal 0. And then this one, x minus 3 equals 0, so therefore x equals 3. So those are my two x-intercepts. One of them is at x equals 0, and the other one is at x equals 3. So let's estimate where that would be. Now, remember what happens. X equals 0 is a multiplicity 2, so it's a bounce. X equals 3 is a multiplicity 1, or a single, so it's a pass-through. Now, we just have to figure out where do we start. Is it high to low, low to high? What is it? What's the end behavior? Now, I can go all the way back up here and answer that question. Actually, I can go all the way back up here. The highest term is x cubed, so it's odd, and it's a negative coefficient. So odd negative means I start high and I go low. So that's what we do. I'm going to start up here, and remember when I hit x equals 0, it's a bounce. So I'm going to have to turn around at some point and go like that, and that's a sketch of the graph. X equals 0 was a bounce because it was coming from a double, and x equals 3 was a pass-through because it was coming from a single. And that's what the equation looks like. It does go high to low like it's supposed to, and it has a turn up here somewhere. We don't really know where it is. It's not in the scope of this class to figure out where that turn is, but it is a relative maximum. We're using function notation in example 5 because some of your homework problems are using function notation. Now, f of x is defined and g of x is defined. Now, the problem is asking for f of x times g of x. This is not fog. This is not f of g of x. This is just a little multiplication dot, so that's all the problem wants us to do. Take f of x, which is 2x squared, and multiply it with x squared minus 6x plus 8. Now, what you probably think you need to do right now is go ahead and do this multiplication. But actually you don't, because remember, we want everything in factored form so we can find the x-intercepts. And actually, we've got it almost in factored form. This trinomial can be factored deeper. There are factors of positive 8 that add up to negative 6. And that would be negative 4 and negative 2. So that would x minus 4 would be one of the factors. And x minus 2 would be the other factor. But don't forget there's that 2x squared out here in front also. So now we have the problem fully factored. So let's put a y equals in front of it. And let's start looking at x-intercepts. This x-intercept would be x equals 4, and it would be a single. This x-intercept would be x equals 2, and that would be a single. But this x-intercept would be x equals 0, and it would be a double. So we know our x-intercepts are at 0, 4, and 2. Now the last thing would be, well, what about the y-intercept? Well, the y-intercept happens when x does equal 0. So in order, that would be 2 times 0 squared, which would be 0. Let's go down here where I have all my factors. 2 times 0 squared would be 0. If I plugged in a 0 right there for the x, 0 minus 4 would be negative 4. 0 minus 2 would be negative 2. So the y-intercept would be 0 times negative 4 times negative 2, which is 0. So the y-intercept is 0. Now let's take all that information we just found and start looking at how would that go onto the graph. Well, remember my x-intercepts. I had 3 of them. 0 was one of them. Positive 4 was another one. And positive 2 was another one. So if I put positive 4 right there, let's just put positive 2 right there. So if I had to label these, obviously that's 0 right there. That's 2. And that's 4 right there. Now, what's the end behavior of this graph? Well, if we go back up here to the equation, I would have 2x squared multiplied by another x. That would be 2x cubed multiplied by another x. That would be 2x to the 4th power. So the leading term would be 2x to the 4th power. We don't care what any of the other ones are, because remember, we said all along, I'm not going to expand this. I'm not going to distribute. I don't need to. So the leading term would be 2x to the 4th power, which is even power, and positive leading coefficient. So one more time, go back to the card. Even power with a positive leading coefficient is high to high. So that's the behavior of the graph, high to high. So that should work. Everything should work if I do that. Now remember, 0 was a double. So I'm going to start high, and when I hit 0, I'm not going to pass through, I'm going to bounce, which means I need to turn around at some point and pass through, and then turn around at some point and go back up. For example 6, we're back to the idea of starting with an unfactored equation. So here it is, and you know the first thing we're going to have to do is factor it. It's one of those that starts with x to the fourth. Again, there is nothing common to all three terms, so there's no GCF. Since this is x to the fourth, I'm going to have an x squared right there, and I'm going to have an x squared right there. Now, what are the factors of positive 36? What are the factors of positive 36 that add up to negative 13? And the two numbers are negative 9 and negative 4. Now, each of those can be broken down because they're both differences of perfect squares. So that would be x plus 3, and that would be x minus 3, and this would be x plus 2, and that would be x minus 2. And I could put f of x equals, but I'm just going to put y equals. It's going to help me out a little bit when I think about the y-intercept. Now that it's in its fully factored form, I know where all the x-intercepts are, and they're all singles, so each one of them is a pass-through. This factor would make negative 3 an x-intercept. This factor would make positive 3 an x-intercept, so try to go about the same distance. And then this factor would make negative 2. And this factor would make positive 2. Now, the last thing I need to know, I've taken care of my x-intercepts. The last thing I would like to know is, what about my y-intercept? Where is this thing going to cross the y-axis? Well, you know what you could do. You could plug in 0 for x if you want. And that would be 0 plus 3 is 3. 0 minus 3 is negative 3. 0 plus 2 is 2. 0 minus 2 is negative 2. So that would be 3 times negative 3 is negative 9, times 2 is negative 18, times negative 2 is positive 36. That would be my y-intercept. There's actually an easier way to find it. Go back to the unfactored equation. The definition of the y-intercept is when x equals 0. So when x equals 0, this would be 0. This would also be 0. So the only thing left in the equation is whatever doesn't have an x, which happens to be 36. So you could do it either way. But we know for a fact that the y-intercept is positive 36. Now, I don't know where it is on this scale. I'm just going to put it right here. And I'm going to say this is 0, 36, the y-intercept. Now, the last thing we have to analyze is the end behavior. And that all depends on the very first term, the term with the highest power, which is x to the fourth power. Now, the 4 means it's an even degree polynomial. And the fact that there's a positive 1 in front of it means positive even tells me how this graph behaves. And if you go back and look at the chart, positive even is right here, high to high. So that's what this graph does. It starts high and it ends high. Now remember, every one of these points is a pass-through. So all you got to do is start high, come down, make a turn, come up, go back down, make a turn, and go back up. Every one of those x-intercepts was a pass-through, so none of them were bounces. Now there's a few last questions down here at the bottom that can be answered by looking at the graph. How many x-intercepts? 4. How many y-intercepts? 1. There's only going to be one y-intercept. The number of relative minimums. How many relative minimums do we see on this graph? 2. One right there and one right there. And then the number of relative maximums, just 1. And that takes care of objective 4.